Hello everyone, so here I am with another MYP task. This task is called the area and height task. It is meant for MYP grades 1 and 2. This is related to criteria B, which is about patterns, and criteria C, which is about communication. Give values to L and H in the diagram. So this is the diagram. Clearly if it is L and L here, it means it's a square. So I'm going to randomly pick up a value, and for my convenience I'm going to choose 10 because that is easy to work with. Alright, and then for H I'm going to give random values starting from 1, and let's say I go to first 5 values of H. These should be quite sufficient enough for identifying a pattern if there is any. Okay, so we have given the value 10 to the length of the square, and H is going to take values from 1 till 5. But before that, it says explore how the shaded areas varies with height. So the two quantities or the two variables that we have are the shaded area and the height. Clearly we have already decided that we will give height the values from 1 till 5. But first let's find out the shaded area. So to find the shaded area, we can clearly see that this shaded area is all the area of this square except for the area of this triangle. So what I'm going to do is I'm going to find the area of the square, which is, as you know, that area of the square is length times the length, that is basically length square. And area of the triangle will be 1 over 2 base. In this case the base of the triangle is this length L, so length, and then height of the triangle is H. Now I have these two, H L over 2, so the area of the square is L squared, area of the triangle is H L over 2. Now if I have to find the area of the shaded part here, I will subtract the area, I'll write it here, area shaded is equal to area of the square minus area of the triangle, which is L square minus HL over 2. For my convenience, I think taking out L as common out would be a good way of dealing with this, because later on we will have to do calculations with it. So I'm going to use this. Area of the shaded region is length times length minus H over 2. So I'll write it here so that we can easily see when we're dealing with the table. So we just found out that the area of the shaded region is length times length minus H over 2. As we decided earlier that we're going to give the length of the square a fixed value, 10, 10, 10. You could have used any other value, but the relationship that we had to develop is between the height of the triangle and the shaded area. Height of the triangle can be given random values, so I'm choosing from 1 till 5. And the shaded area, let's calculate the shaded area. I'll do 1 to 2 examples with you, and then I'll leave the rest to fill by yourself. So if length of the square is 10, so that's 10, and then 10 again. The height of the triangle for the first part, we say that this is 1 over 2, so this is 10 minus a half is 9.5, so the area is 95 when height of the triangle is 1. If you increase the height of the triangle, what do you think? Would that be increasing or decreasing? Let's find out. So again, the area of the shaded region is length times length minus H over 2, and this time we're going to calculate the shaded area when the height is 2 here. So let's see, this is 10, this is 10, and this time this is 2. So 10 times 10 minus cancels out, so 10 minus 1, 9. Right, So this formula really works for us, and you can see from the diagram as well that as the height will get bigger, the shaded region will get smaller. So here we are. I'm going to fill out the table as I've already done the working. So this is 85, 80 and 75. Now I'm going to do is I'm just going to leave this one space for you again let's just do it for the one last time. So there we are. This is 70. Now the word is explore the shaded area, explore how the shaded area varies with age. What we have done so far is we found the area of the square and the triangle, then we found out the shaded area by taking the difference of the two. Then we use this formula for shaded area to find the shaded areas when height has its certain values with the length being constant. Now let's study this picture. What does this picture say? Length is constant, so we're not looking at it. Height is increasing by 1 each time. You can clearly see. And with this increase of 1 unit in the height, look at the shaded area. It's being decreased by 5 each time. Right, so when we have to explore, it's always a good idea that you try to state it. So increase of 1 unit, whatever the unit is, in height h of the triangle results in decrease of how much? Of 5 units in the shaded area A. Right, so keep this keep this statement in mind for the next part. Okay, in this part what we have to do is find the general rule. Just to keep in mind, we have to find the general rule between the shaded area and the height h. This height is the height of the triangle. So we have to find a formula which gives us the area for any particular value of h. As we studied in the last part, that this is decreasing by 5 each time. Nevertheless, increase or decrease, it is being changed by a fixed value. In that case, this shaded area, this sequence of shaded area is an arithmetic sequence. Remember, arithmetic sequence is the one which is obtained by adding or subtracting a fixed value. In this case, it's the -5, and this -5 is also called the common difference. Right, so the essentials that we needed to find the formula is the common difference. Common difference is -5, and the first term of this shaded area, we'll call it A1, that is 95. The formula for arithmetic sequence, the general term of the arithmetic sequence is AN. In this case, I'm using H, so AH is equal to A1 plus H minus 1 times T. Guys, this is a fixed formula, and you will have to learn this formula, or you will be provided this formula in the formula booklet, the formula for arithmetic sequence. Now we just have to fill in the values. Our first term is 95 plus H minus 1, and common difference is -5. It's just about simplification. So AN is equal to 95. When -5 multiplied, it gives us, when -5 multiplies inside, it gives us -5H and plus 5, which results in 100 minus 5H. Yeah, so finally what we have done is we found the general rule for the relationship between the area of the shaded region and the height edge of the triangle. You may want to test it for some values that we already know. So let's do it for this one. When age is 3, do we get 85? Let's test. A3 it's 100 minus 5 times 3, so 100 minus 15, that is 85, and which is the same number. So our testing is quite good enough. We've got the rule working here and it is correct with the findings of our table. Alright, part 4 says justify your general rule, how your general rule works for any case of the pattern. So for that I've extended this. We constructed the table till 5 and now I have extended this here. We can extend it further and this will be 65. If we were to extend the table in the same pattern, decreasing by 5 each time, we get 65. So that's the information from the table. Let's see if our formula also works. Our formula says AH is equal to 100 minus 5H, and for 7, the 7th area will be 100 minus 5 times 7. 100 minus 7 5 is 35, and this is 65. So you can see that the two answers are same. But for the examiner, remember, this is the critical point. For the examiner, this doesn't end here. When you are justifying, this is a very crucial command term in the IB. So when you are justifying, you have to claim. You don't have to write the word claim, but you have to make a statement that the table value is the same as the value from the formula. Just writing this little sentence completes your job here, that you have to justify. Okay, in this part again it's very interesting. So explore how the shaded area varies if the square is replaced by a rectangle. So I'm going to call this length as L and this length as H, because rectangle has two different lengths, and this height of the triangle as small h. Alright, like before, I'm going to find the area of the rectangle. So area of rectangle is simply length times the width, or length times the height in this case, and area of the triangle is 1 over 2 times the base. This time the base of the triangle is again this length, so that's L, and the height of the triangle is noted by the small h. And the shaded region that I have to find, the shaded region is the difference of these two. Is the difference of these two areas. We will take out the area of the triangle. This is what we do not want. So the area of triangle is to be subtracted from area of rectangle. Area of rectangle minus area of triangle. This is length times h minus half times length times small h. So we can generalize this at, this is the shaded area. So you can see that L is common, so I'm going to take that out for convenience of my working. It's not necessary, but normally if I would go manual working, I would prefer this one. So this is the area of the shaded part if it's a rectangle. Now we have three different quantities: the length of the rectangle, the height of the rectangle, and the height of the triangle. Keeping this formula in front of us, again using random values, so I've given the height of the rectangle as 10, the length of the rectangle is 20, and the height of the triangle is what we are going to study. Again, the study is between the shaded area and the height of the triangle. Let's fill out these values. Again, using substitution like before, I'm going to fill out the table here. So that's 190, that's 180, 170, and I know you can predict yourself, 160, 150. Right, so in this case, with each increase in one of the height of the triangle values, what's happening? This time we have the shaded area changing by 10. 190 is becoming 180, so it's decreased by 10, and this is a consistent decrease. It is decreasing every time by the same quantity. If it is changing every time by addition or subtraction of a fixed value, then this is an arithmetic sequence. Okay, and this fixed value is the common difference, as I mentioned before. The common difference is -10. The first term of this sequence is 190, so I'm going to say A1 is 190, and the general rule here, it is A8, so A8 is equal to A1 plus H minus 1 times D, and plugging in the values, we have AH is equal to A1 is 190 plus H minus 1 times -10. And when you simplify that, what do you get? You get 200 minus 10H. So what we have done is we have found the area of the shaded region in case this is a rectangle. So that's about it. Thank you.